Okay, I will share my slides. So can you all see the slides?
Yes.
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 Yes, no problem. Yeah.
Yeah, we can see that.
Okay, well, at the end of the session, we will basically share the slide with you. So don't worry, you will get the soft copy of the slides, PDF version. And also along the way, maybe I will also explain what will happen. We will have a break at 10:30 and come back for about 15 minutes, 10:45 for morning break. And after that, we'll start again. And lunch is at 12:30 until 2. Okay. And then we will continue with the modules until maybe around 3 o'clock to have another break before we finish at about 5. Okay, so it's 9 to 5 session. And normally we will do this in a classroom environment, but today we have to adapt to the new normal. So I hope that this session would be beneficial to everyone. Okay, so this is the journey for these 2 days. We are going to cover about 6 modules. The first modules we'll be talking about understanding of IoT and big data. Basically, to get you guys up to speed on some of the terms, so that when you talk to people, at least you will be able to make sense of what they're saying. So I have to say that when I first got into IoT, it's very, very confusing for me. And a lot of the terms is something that I have to learn along the way. Is that you? Okay, so the second module is going to be looking at impact on the business. So IoT and big data impact on the business, and also give you some snapshot on the market overview, how it looks like in terms of IoT implementation, IoT investment in Malaysia and also globally. Okay, and we will basically close the day with module 3, which is creating value from IoT. So this is actually one of the most important questions, that if we go to each companies, this is the thing that they will be looking at. Basically, this module will give you some sort of like example on how from the data that you track, the data that you gathered from IoT sensors, and how are we going to create value from that. Yeah, this is a question that mostly everyone will be asking, whether or not IoT solution really does it work as we suppose. How does it work? Yeah, basically. I will focus on some certain things like the kind of activities that you have to do in order for you to extract the value. We'll be talking about information value loop. This is a term coined by some of the most proponent IoT consultants, Deloitte. So they come up with this concept of information value loop, where you have to complete the loop in order for you to extract some information. Okay, and I will also share with you how the best business model for IoT, which is IoT platform. So we will share how you can actually exponentially increase the value of your IT by making it a collaboration or ecosystem platform. So this is the best basically value extraction method, if I had to term it that way. Okay, tomorrow Beginning of tomorrow, we will start making some technical stuff. We'll look at what makes up the building blocks of IoT. So IoT architecture, the key elements that you need to have in order for you to have the whole complete solutions. Okay, some of the key infrastructure is like sensors, network, standards, some augmented intelligence and augmented behavior. So that is basically analytic tools and also robotic feedback loop. And then I will also share with you IoT applications, the case studies. We will share two of our past case studies. One in agriculture, and the other one will be in logistic. And we will also study some of other cases that our partners have, particularly using six-fork networks. So hopefully the case studies will give you a better understanding on how people are using IoT to extract the greatest value or to solve their problem, basically. And we will close the session in the last module, which we'll be talking about issues and challenges. So when you wanted to basically started looking into solution for IoT, so you need to consider some of these things like security, privacy, legal and regulatory rights, in order for you to avoid some of the problems that you may have, because these are the key issues that not just IoT per se, but applies to internet nowadays. The connectivity, or basically connected world, if I can summarize it. Okay, so I think that's quite a long introduction before we actually start the journey. So we have about 1 hour and a half before we take a break. So let's start the journey. Okay, the first module we were talking about understanding IoT and big data. So, okay. There are two things in the world, in the word Internet of Things. So you have internet connectivity that connects various kind of things, durable goods, consumer products, sensors, everyday objects, drones, car and trucks. So all these are now you can connect it, and together with data analytic capabilities, together with predictive analysis, for example, we will be able to extract a lot of values and get more from the system that you have. Okay, and all this actually realizing it or not is already transforming the way we live, the way we work, and the way we play. Okay. In a nutshell, what is IoT? Okay, IoT is the Internet of Things of a system of interrelated computing device, whether it's mechanical or digital, objects, animal or people that are provided with unique identifier. So every object that basically connected into this system has to have a unique identity. Okay, so that they can differentiate themselves. So let's say, for example, you have machines, machine 1, machine 2, machine 3. Okay, you need to differentiate between what machines. You cannot have the same ID, for example. Okay, and the other things that basically defines IoT is the ability to transfer data or communicate, in a sense, over a network without human to human or human to computer interaction. So that is the key definition of IoT. Okay, from generally accepted definition that most people would define IoT. But I have to say that there are no single definition. Okay, the term itself, the term IoT or Internet of Things, is coined by Kevin Ashton. Okay, In his book, Making Sense of IT, he defined the Internet of Things means that the sensor connect to the internet and behave in an internet-like manner, okay, by making open ad hoc connection, sharing data freely, and allowing unaffected application, so computers can understand the world around them and become humanity nervous system. So when internet first comes into our life, I think 20, 30 years ago, normally what we connect is people. And IoT bring in another dimension, which is things, so physical things into the virtual world. So not only then we connect between people, the social media, for example, is connecting people, and but now we can also connect with our home, our aircon in your home, for example, you know, in your car, you can connect to them by internet. Okay, I will share with you when we ask people in the industry, for example, how would they define IoT? Okay, I share with you some of the survey that have been done by Hewlett Packard, HPE Aruba. Okay, so they ask a question of what are your understanding of IoT? Okay, so most people, okay, define IoT by their own definition, is adding internet connectivity to everyday object. Okay, in a way this is correct. Okay, but according to Kevin Ashton, the pioneer that coined the phrase Internet of Things, if the internet means product like this, that means you have a thing that is connected to internet, a little more than say home appliance, and add the word smart to it, it will not be interesting. As in, it can only give you information. Okay, so IoT goes a step further actually, where the thing can do things for you, not just inform you. So this is what it really means. So yeah, it's true, adding internet connectivity to everyday object is true, but it also means that the things can do things for you. Okay, so some other definition that people coined to understand what is IoT is for example, 65% of them saying that it's a network that connects multiple objects or device or sensor. 55% of them saying that it's a platform, okay, to connect industrial components. Another 52% says that it's automating building services, and 45% says what is that? Fancy. Using wearable technology. Okay, and then you have this United Nations International Telecommunication Union. So I think in 2010, okay, they came up with a recommendation for IoT, and they have their own definition. So I can say that this is probably standard IoT definition. You can say that IoT can be viewed as a global infrastructure for information society, enabling advanced services by interconnecting physical and virtual things. Okay, and based on the existing and evolving interoperability information and communication technologies, ICT. So there are two things that makes up IoT: physical things and virtual things. Okay, and physical things and virtual things is connected through a network. Okay, it can be integrated into a communication network, and each of these things have contained associated information. Okay, for example, in virtual things you have multimedia content, videos, pictures, application softwares. And physical things is your surrounding environment, your temperature, your humidity, your robots, your goods, your equipment. So all these are basically integrated into a communication network. And this concept basically start with a vision, okay? And this is a vision that actually have a very big implication in terms of technology and society. And through technical standardization, okay, because it's too broad, you know, so people need to basically have a standard in terms of technicality. So we will basically share with you what it means by having a standard later. And it's actually one of the key challenges that people today are having, to have one standard that everybody can relate to. Okay, and this standard creates a global infrastructure. Okay, and it used for the information society. Information society is us, basically. Everybody that actually make use of data, make use of information every day. And with that information, okay, you enable some services. Services means analytics, you know, process where you can understand things in real time, understand things, how things can improve, for example. Okay, and this information by you know, connecting them up, looking at the overlaying, say for example, data upon data upon data, and then you will see some patterns. Okay, and this is where you exploit the process to tadi, the data capture process, the communication capture, okay, the identification of objects, and then offer all this into a service in the kind of application where you can view, where you can have something like a report, you know, where you can have something like active action or active recommendation. Okay, that is basically how the concept of IoT, why people use IoT. Okay. Okay, let's talk about other kind of like terms that is similar but not the same. Okay, when we talk about people in industry, people are talking about Internet of Everything, for example. There's also industrial internet or industrial Internet of Things. Okay, there's also a term like Web of Things, M2M or machine-to-machine communication, Industry 4.0. So all these are the term, but they don't exactly mean the same thing. Okay, this is some of the definition study or concept disambiguation to differentiate between all the other basically terms that overlap or with IoT. Okay, if you look at the graph, I think this is done by Cisco. Starts from machine, objects, people, and the world. So it basically tells you what area of coverage of each of the terms. Okay, Web of Things is only cover the virtual world, but you connect machine, objects to people. Say for example, this is Web of Things. The internet, mainly talking about virtual world and connecting people. Okay, so Internet of Things connecting people, objects, machines, and virtual and physical world. Okay, Internet of Everything is much larger kind of concept. So basically it connects everything, for people, process, data, things, and to make network connection more relevant and valuable. Okay, and maybe you have heard Industry 4.0. Okay, if Industry 4.0 is a revolution that basically pushed by the German government, and the terms normally only basically only used by the industrial people. Okay, but it actually means same thing. So it more focused on machine-to-machine kind of connections, but it also overlap with the machine-to-people kind of connection. Okay, so I'll give you some definition, just a bit of a basically introduction on all this. So M2M, also known as machine-to-machine. This is well known in telecommunication sector. Okay, initially it's been one-on-one in connections linking one machine to another, but today it has much wider devices due to mobile connectivity. Now you can also interface between human. Okay, industrial internet. Okay, this is terms coined by GE General Electric. Okay, this goes a little bit beyond M2M, since it's not only focused on connection between machine but also includes human interface. IoT, we have already discussed this, wider reach that includes connection beyond the industrial context. So it can also include your device that you wear, for example, your smart phone, smart watch, for example. The internet, I don't have to explain that. So we all know what internet is. The web of things is much narrow scope as the other concept, and it's solely focused on basically virtual kind of application, and so it's mainly focused on software between, let's say, you have one software that takes data from another software. So, for example, like that. Internet of everything, right? The vague concept, it's basically encapsulates everything from people to machines, and applicable to like every industry and everything that we have touched on. Okay. Industry 4.0 strongly pushed by the government, like say German government last time. I explained that, and it's limited to industrial internet as it's only focused on manufacturing environments. And it also kind of like the driver for Malaysia as well. When we talk to government MITI, for example, so these are the one of the driver that the transformation that people in the industry has been pushing for. It's kind of like you have to get into the bandwagon or else you will be left behind. So it's a powerful concept, and I think it's the most popular in terms of the term itself, the use in the industry. People probably will more recognize in IR 4.0 or Industry Revolution 4.0 in comparison of other terminology that we have seen previously. Okay, so that's IoT. Okay? So you might be wondering what is big data and IoT, right? So I will try to explain the relationship between the two. The relationship between IoT and big data. IoT, if you can say, is generating data, and big data is collecting those data. They are interrelated, but they are also quite distinct. Yeah. IoT consists of millions of devices. Okay, like I said, it sends physical events or physical things that is happening around us, and then communicate that. And that are the data that you produce and you basically compile in a big, larger data pool. Okay. If we constrain IoT with just devices, okay, information not just coming from the device itself. Okay? I give you example. In a farm, for example, okay, what things that are most important to the plant are probably you can put sensors to it, like pH, like moisture, temperature, okay. But it's also related on to the things that people do. The farm workers, for example, So farm workers will have a log. For example, what are the tasks that they need to do? Those are data. And big data basically takes the sensor data plus whatever that the tasks that the people do. And that overlapping those data on top of each other and see the patterns and come up with sort of like a trend analysis, or understand what is going on. That is big data. Like its title, big means tremendous amount of information, and it comes from all kind of sources. Okay, even when we speak, we give information, right? Those information also included in the big data by definition. Okay, you can basically, if you want to measure big data, it's not in terabytes anymore. It's in petabytes, exabytes. So it's very, very big at the moment. Okay. So how do you basically create value from big data? So if I can just basically go through the process. Okay. First, you generate those data. Computer technology have enabled organizations to collect big data sets, and later I will show you how much now enterprises or companies around the world are generating data. Okay, it's getting bigger and bigger and bigger and bigger. Okay. Second step is the aggregation of data. Aggregation meaning you start to compile and then sift through those data in search of insights that you can assist you in decision making. Okay. When you start to look into those data and you do analytics, and normally we have a term called the big data analyst. Our company, for example, have a few teams of data analysts, we call them. We're not really engineers per se, but some of them are coming from engineering background. So these analysts, they use modeling software, statistical method to make sense of the patterns, performance information, and also to look at what are the potential problems that could be having along the process of running the business. And from there, okay, you compile that into something called actionable reports. Okay, so you know what is happening. Okay, and you kind of like can anticipate the potential problems that you may have. Okay, in order to avoid that problem, you can recommend a solution or actionable items, so I call it. Okay, so you turn this big data into useful reports complete with action plans to extract values for the organization, and that is still a human kind of is still done by human, right? And the next step, the last step, is to apply machine learning and artificial intelligence. Okay, when you collect the data, okay, you do it manually at first, right? So when you started to have prediction model, okay, for example, you have technologies that you can enable the computers to do some of those things that you do manually. Say, for example, I take a picture and then I look at the logs and I key in the logs. So all the actions that has been done by this department or that department now have been recorded in a spreadsheet. So with current technology nowadays, you can actually automate that. You no longer have to do it manually. So, and while they're doing that, you can apply, there's a programming method that you can apply when you set that, for example, program that automation to keep learning of the patterns and adjust. So Example, example, if I wanted, I got say the delivery order, and then I scan that delivery order, and then I basically key in the data from the PDF that I have. Okay, and some of those numbers sometimes doesn't make sense. So maybe it's a typo, for example. So you kind of like, okay, this data is not credible. So you need to say, okay, actually it means this thing. So you adjust it yourself. So now with machine learning or with predictive model or kind of like programming, you can teach the machine to differentiate, started to differentiate what data is good and what data is not, say for example. And it's not entirely to completely replace human in terms of doing the work, but rather than that, it complement the work that we do. Basically, you can do it now faster with these machines helping you. Okay, because most of those things sometimes are very repetitive, and if you automate it, it becomes faster. And all you need to do is, maybe double check the work that the machine does for you. So you just make sure that the outcomes, the recommendation that the machines are giving you is something that making sense to you, basically. Okay. And big data, if I wanted to explain or to people the concept of big data, there is one very popular concept, and it's actually popularized by IBM. The concept called 4V: volume, variety, velocity, and veracity. Volume means is data collected today through sensor or online transaction or social media and all other mediums cannot be processed or stored using traditional method. So the volume is so massive that you need really huge storage for you to store all those data. So when people say, oh, it's a big data, that means the volume is huge. Okay, not just the volume that is huge, it's also contain a lot of variety in terms of data, a wide range of types, from social media posts to video clips, to digital data that cannot be correlated into any traditional structure, so unstructured data and structured data. So it's a lot of varieties, it's all kind of things inside there. So those are concept, one of the concept in order for you to define big data. The other dimensions is the velocity. And this data that you are collected is generated at a very high speed. We're talking about 2.5 quintillion bytes a day if you compile everyone. Basically, every data that is generated in the world. Okay, hundreds of thousands of social media posts, Google, people is updating what they are doing. Everywhere they go, they tell people that. So it's a new world that we are living in. And the last V is the veracity. It refers to truthfulness and accuracy of particular set of data. So again, I said just now, I explained, when you take the data, traditionally it comes from various sources, and some sources are the human itself, and human tends to make error. So when you first see the data, you probably will say, maybe this is not right. The accuracy is not there. It's not truthful. And this happens everywhere. And then we are living in a world where we very difficult to basically distinguish between truth and false, right? People are just creating fake news every day, So these are the other concept or other the last V. I was here to explain the big concept data. So last, veracity, which is related to truthfulness or accuracy. And this 4V basically defines the term big data. Okay, I like this analogy to explain the relationship between big data and IoT. In one sense, IoT, you can imagine it as a series of creeks and rivers that feed into an ocean of big data. Okay. IoT creates data and it gives this data into a pool, a server, a cloud, or whatever, that you basically you collect all those data with all other sources around us and contribute to the big ocean. Okay. The enormous collection of connected sensors, devices, and other things that represent IoT, we were talking about 7 billion worldwide, is making significant contribution to the volume of the data collected. Okay, the tools that we created for big data and analytics are useful for correlating and the data streaming into from the IoT device. So IoT more focused in having an ecosystem, or rather platform, and software and application that enterprise and organization can use to manage their devices and also manage the data that they generate. Okay, so I think that is quite clear in terms of the relationship between big data. Okay, let's now look at the details of the distinction. We say that it's distinct, but it's complementary between IoT and big data. IoT, for example, it seeks to run analytics simultaneously, and it supports real-time decision. Big data, however, collect large sample data, okay, run analytics, and later for decision. And later you can use it for decision. So it's not really real time. So what I'm saying is that because traditionally big data is done by data analysts, so it's done by humans. So first you need to have that pool of data before you actually make any analysis or looking at the insights that you can get out of those data. And the decision for you to make it, to make action, comes after you look at all those patterns and analysis, okay, results. I give you one example. For autonomous car, for example, data cannot be put aside for later analysis. So you need the data, you need the decision to make decision instantaneously, because if it shows, say, for example, impending an accident, machines need to know those results without delay. So that can be done with IoT. It's too late if you take all those data, you send some collision that might happen, and then you send it out to the team at the back, and then study, analysis, dapat report, then number decision it doesn't make sense, right? So IoT supports real-time decisions. Big data more towards say company e-commerce, let's say, that might track consumer habits over time and use that data to create a tailored content or advertising for consumer later, or even change their business process, for example, change their strategies, change direction of the company going, for example. So it's distinct, it's almost the same but complementary. Okay, many IoT devices rely on cloud computing ataupun communicating with remote server. Okay, but nowadays, people are starting to having problem in terms of traffic. The data that is generated all go through one cloud, and the traffic of the data became a problem. So we are starting to see a movement towards what we call edge data processing. That means you do some processes. Traditionally, you used to do processes in cloud, but now they are moving towards having those decision-making processes or analysis or data processing as close as possible to the source of those information. We meaning you have sensors, a device that gives you data. Before you send the result to the cloud, you do the analysis there and then first. So you need some sort of like capabilities in terms of your device to be able to collate, make analysis and do prediction, suggest corrective action, for example. And you only send the data off after you processed it. So basically the result over the cloud. Okay. So in that sense, in this model, okay, the device retains the power to process data locally and ensure minimal latency for sensitive operations. So dia tak ada delay in terms of making decision. While in big data, analysts use modeling software and statistical method, statistical analysis, usually performed in external PC after extraction from the information from the server before identifying patterns and performance improvement later. IoT is centered on machine-generated data. So I have to say that because it's things, most of it, the data that is generated is either from sensors, device, and its primary goal is also machine orientated. That means your information or what you want to get out of it is also something that can be taken action by the machine itself, and that is also meaning that whatever decision you make is related to that machine. Okay, for example, your equipment performance, predictive maintenance, or asset tracking. So these are the kind of realm that IoT plays on. Okay, and big data analytics pula typically looks at human choice. Okay, and we saw this a lot in online social media marketing, for example, and they use patterns to look into behavior of human, how human make their decision in buying stuff, make their decision in where to go for holidays, for example. So it's more related to or close to human choices. Okay, so those are big data. Okay, but there are also complementary case. Let's say, for example, predictive analytics, machine performance and service alerts over time. So machine performance, normally we need real-time data, real-time status of the machine. So that at any point of time, I wanted to know, say for example, that machine is producing how much parts, for example, or how much of those assets is being actually used today, for example, 70% or 80% utilization rate. Okay. But while you are actually looking at real time, you also collecting all those data in a library again, and later you do big data analytics in order to anticipate upcoming problems. So what that means is that these companies now can be proactive about maintaining their equipment. They can ensure spare parts or servicemen. Okay. On the hand before actually the machine broke down, because when the machine broke down is already too late normally. Okay, you will have downtime and you will affect your production, you will affect your service to your customer. All right. So all this big data and IoT are technically having the same goal, a common goal. For example, they are distinctive ideas, but they depend on each other for ultimate success. Okay, both of the concept emphasize the need of converting the data into tangible insights that can be acted upon. Okay, so I give you another example of IoT working together with big data analytics. Say, for example, you look at shipping companies. Okay, shipping companies nowadays are attaching sensors on your trucks, not just trucks. Sometimes they put it on the consignment, on the basically the goods itself. Yeah, to keep track of either information, the status where they are. You know, in the case of trucks or moving vehicle, you know, looking at the speed, the stop, the engine status, for example. Okay, and they use this data to make immediate decision and to anticipate forthcoming problems. You know, say for example, if I send one of my finished products from my factory to say the distributor's warehouse, for example, and along the way, I need to be able to know where my drivers are. Okay, and I have say a time that is set to me that the driver must arrive at the customer location. Okay, and customer will at any time will be able to just call me and ask where they are. So I need to be able to know and to tell the customer that is on the time, on the way, okay, where they are now and what time they will be arriving there. So we're talking about visibility here. Okay. And then at the same time, while doing that, I can track how long or how much mileage has the truck or my vehicle have been moving. So I can predict when I need to schedule the next for maintenance, for example. And in order for you to do that, you accumulate first the data that you gathered, and then you do cumulative analysis. Cumulative information to get a big picture of how the process is being done. Okay, that is one example. Okay, all right. So it's a long way of explaining the terms. Is a big concept, and I have to say that when I first started looking at this thing about 4 or 5 years ago, it was really confusing. And the more I read stuff about IoT and big data, it just basically keep confusing me. So I hope I also don't confuse you guys. Okay. So you can have these slides later and get the information by looking at it again. So I'm pretty sure you also have done your own research on these topics. So maybe you find something different. I don't know, but it's basically the idea most probably will be the same. So the next section I will be talking about history of big data and how they come together. So I have a timeline. It's quite a big timeline. So if you want to talk about communication, electronic communication, you have to go back to like really early, in 1918, for example, the first electromagnetic telegraph created in Russia. Okay, and they invented their own code to communicate over a distance in Germany, from Russia to Germany, right? For example. In 1844, sorry, and then Morse code. If you remember what Morse code is, that is the earliest form of electronic communication, one of the earliest form of electronic communication. In 1912, the first telemetry system was rolled out in Chicago in 1912. Okay, and they actually used these telephone lines to monitor data from the power plants. So very early in the 19th already, we are seeing that people are using telecommunication technology to gain data and insights to manage our services. 1930s, you have a device known as radio sound used to monitor weather condition from balloons, for example. 1957, Soviet launched Sputnik with it. basically the first rockets to the world. Internet comes about in around 1970s, actually 1969. So the internet, the first basically project is called Advanced Research Project Agency Network, ARPANET. So that is the first wide area network, and the first network to introduce. You know, if you are in the IT, you know this TCP/IP protocol. Connected with computers. In 1979, system for remotely monitoring meters on electrical grids, telephone lines. Okay, 1984, 1989. So these are the era where internet started to get into our life. Okay, when you talk about IoT, actually, it started really the internet connected with things in 1990s. The first IoT device is a toaster that can be turned on and off over the internet. And then you also have a coffee pot in Cambridge, where basically that pot, the coffee machine, is connected to a camera that is you can view it from the internet. So they connect the coffee pot with the internet. Okay. It was not until 1999 when Calvin Ashton actually coined the term Internet of Things. And at the time, he was executive director of Auto ID Center. Auto ID is actually the company that developed RFID. Right now, RFID is now being used almost everywhere. If you looked at, you know, now our toll is also now using RFID. Some of the stores that you go, say for example, last week I went to Decathlon, you know, they are using RFID. They no longer have the stack or barcodes anymore. Okay. And RFID is also, I can say that one of the key technology enabler for IoT because of its ability to send data without, you know, being tagged. As long as you are within the range of the RFID reader, you'll be able to sense that or transfer those data. Okay, so IoT takes off. Okay, is gaining popularity since 2010. Okay, at the time, if I still remember, you know, you have Google View started to basically making rounds along the streets, you know, to take. And along the time, the people are saying they are actually sniffing Wi-Fi connection to make that 360 degrees, you know, 360 degrees picture. At the same year, also, Chinese government announced that it will make the Internet of Things a strategic priority in their 5-year plan. So that is probably why they're having the project and you know, pushing things for 5G because they have been making this thing as their priority back in 2010. In 2011, Gartner, okay, one of the famous market research company invented the famous hype cycle for emerging technologies. I'm not sure whether you are familiar with this, but this is actually a very good graph or method to explain all kinds of technologies that people in the world is talking about. When we call hype cycle, later I have a slide to explain what is this hype cycle and where Internet of Things started to be on the picture. All right, so this is in 2011. When you see hype cycle for emerging technologies is basically looking at expectation of whatever new technology that they first started in, gaining traction in the market, and ideally, okay, what happened is that every new technology will go through this cycle. We call a technology trigger. So they're beginning to gain traction, gain recognition, and people are starting to, play around with it, starting to understand it, how it works. They will be going. I lost connection just now. Hello? Can you hear me?
Yes, I can hear you from here.
Okay, sorry. I think I lost internet connection just a bit. Okay, so I'll continue. So the peak of inflated expectation, this is where everybody is talking about it. Everybody is trying to jump into the bandwagon, and where the hype is all about. And after that, it will drastically go down into a period what we call true disillusionment. So whether it's real or not. So this is the curve where each technology have to survive through, in order for them to basically go to the market and actually become a normal life, part of our normal life. Okay, and the next basically period is called slope of enlightenment. So this is where people are started to see what is the advantage, whether it's practical or not, whether they can actually commercialize it. And last is the plateau of productivity, when the technology is actually beginning to extract value from to be able to extract value from them. Okay, to produce something for the people who are using it. So first, Internet of Things and Big Data happened to be on the picture in 2011. In 2013, yeah, you can see that first, you look at previously the Big Data is coming actually before Internet of Things. And then 2003, Big Data quickly overtake Internet of Things. It become the most hyped thing in the world at that time. Okay, it reaches the peak in 2013, Internet of Things. Internet of Things slightly slower, 2013. 2014, Internet of Things is at the peak, at the height. So everybody is now, trying to understand this new technology and try to be part of it, try to understand, to implement it. And while big data is quickly now going through down the disillusionment period, and surprisingly in 2015 it's gone off the chat. So big data, and people ask Gartner why suddenly it got off big data. Okay, and Gartner gives this reason: big data has quickly moved over the peak of inflated expectation, and it has become prevalent in the lives of many hype cycles. So that means it becomes part of many all other analytics. Okay. Now I did not jot down here, but in 2015, Internet of Things is still at the peak. It started to go through the disillusionment period. Okay. And in 2019, it has become quite a norm actually. Sorry, the question here?
Chang, you got any question?
Okay, so Gartner created specific curve just for Internet of Things. Okay, if like I said just now, Internet of Things is quite a big concept. So if you looked into it down further, there's actually a lot of enabling technologies that IoT carry on, carry as part of it. Okay, so Gartner created this hype cycle for this is last year 2019. Okay, so because it's a real thing now, and some of these elements of IoT are already being implemented or starting to produce productivity. For example, indoor location asset is already been implemented and people already extracting the value out of them. The IoT integration, asset performance management. So these are the key or the kind of like part of technology IoT that have gained more traction compared to the rest. Okay. And along the way, IoT also have certain things. Certain new technology that backed it up, say for example, Internet of Meat, itu benda baru juga. IoT enable application, edge computing or edge analytics. So just now I talked about how initially people are using cloud computing, but now quickly there are people are looking into edge computing. So I will explain that what it means, and if you have any question on those terms, just shout out ataupun just use the chat function. So Farhan will be looking at the chat function, so that, if there is any questions, we can pick it up from there, and I'll try to answer that. Okay, let's make this thing a bit more interactive. I don't know how to do it, but yeah, I'm encouraging people to ask questions. Okay, so that's all about history of IoT. So you may be wondering where drones comes in, and I have a section where I will explain the relationship between IoT and drone technology. So by the end of this module, the first module, we will basically look at the relationship ataupun the connectivity between what is the drone technology and the IoT technology. In fact, there are drone is a subset of IoT. So this next section now will be talking about fundamental characteristic of IoT and its high-level requirement. So before you set up any solution or any program or deployment of IoT system, so there must be some high-level requirement that you have to fulfill. So I will be sharing with you what are those things. What are those things that basically set by some of the people in the industry. First, let's understand what is the characteristic of IoT. Okay, Internet connects people, basically, primarily people, and with the mobile phone that we have, we can connect at any time or any place. Okay, anytime communication, in any place communication. So whether we are on the move, whether at night or daytime, we'll be able to communicate with people. Whether we are outdoor, indoor, away from computer, or at the computer, we can connect. And IoT adds the new dimension, meaning anything communication. So means that not only we communicate people, we can communicate human with computers, things or machines with machines, okay? And the concept is at any time and any place, meaning the thing can also communicate at any time and any place. So these are the dimensions of IoT, and these are the dimensions that is introduced by E2, International Telecommunication Union. Okay, let's look at the technical overview of IoT. As I mentioned just now, it consists of two things, virtual things and physical things. So you have two worlds here, physical world and information world. Okay, a physical thing. Okay, let's say my computer or me yourself. I'm a thing, basically. I'm a human guy. I can be represented in the information world. So if I have an account, social media account, so that is my representation in the information world. So you can also have these machines or whatever things in the information world. So this is what we call mapping. So you have physical thing and you have virtual thing. And these are mapped through this double dot gray arrow. Virtual thing can exist in information world without any association with the physical world. But physical thing cannot exist in the information world without the representation. Okay, that makes sense, lah. Huh? So, in order for the physical things or physical things in the world to connect to the information world, you need to have something called communication network. Okay, and for them to get into the communication network, you have to get through these things called gateway. Gateway ni kira macam your Wi-Fi hotspot lah. Kalau in office environment is your server, sorry, not server, Wi-Fi hotspot. Server itself connected, it contains the information world. So if I can explain what is a device, okay? Device is a piece of equipment and with the mandatory capabilities of communication. So in IoT, the first thing that a device has to have is the ability for it to communicate in through the network. Okay, and this device collect various kind of information and provide it to the information world through these networks, and it also basically executes some operation based on the information received from the information network from the ICT. So it both two ways. You give information and you can also receive information and act upon it. Okay, let's look at how device communicate with each other. You look at this line here, A and B, A, B, and C. Device can communicate through different way. The first method, the case A, is they communicate through a network via a gateway. Or they can also connect to another device without going through the network. You can have the wired network, not going through the communication network. And case 3 is, just case B just now, is the case where the device go through, connect to another device through the gateway, Case C is a device connect to another device without going through the networks, without going through the gateway just now. So all these are the technical overview of IoT. Now, this is the concept, okay? You have P2P, which is people-to-people communication. Basically, this is the internet. And then you have machine to people, So whatever you view from your application, from your mobile phone or your computer, your laptop, those are the M2P relationship. And last but not least is M2M, which is the machine to machine. So Internet of Things comprise of these two, the machine to people and machine to machine connectivity. Okay, so I will share with you what is the fundamental characteristic of IoT. So when you talk to people, or when you started to think of what kind of solution you need, that have IoT in it, it has to have this fundamental characteristic. The first characteristic is interconnectivity. Okay, IoT means that anything can be interconnected with the global information and information structure. Kalau your drone, for example, is standalone and cannot connect to the internet, that means it's not an IoT drone. So it's a drone, it's a machine, but it's not an IoT machine. Okay. Two, the second characteristic is things related services. Okay, IoT must be capable of providing related services within the constraint of the things. Yeah? For example, privacy protection, semantic consistency between physical things and their associated virtual things. Okay, and these services ni maksudnya basically like real-time positioning. So that is a service. Real-time monitoring of the condition, that is a service. So you need to have something that that means you provide services to other machines or to you as a human. Okay. The third characteristic is the heterogeneity. Okay, like I said just now, in the first session when I introduced IoT, every IoT device need to have their own ID. So based on this, it need to be able to work with different platform or network. So kalau your IoT is a closed system where you cannot use it for other networks, it's not truly, in a sense, IoT. Because Internet of Things connect things to other things. And if you cannot connect using another type of network, for example, it's not heterogeneous enough, something like that. Okay. The fourth characteristic is the dynamic changes. Okay, the state of device need to change dynamically, either it's sleeping or waking up, connected or disconnected. Okay, and all this in the context of let's say information that you need the device to give you. For example, location or speed. Okay, I'll give you one example. An IoT sensor can give you, say, data at any intervals. Okay. At the same time, they can also give you data at certain events. For example, if I'm talking about GPS tracker, for example, when they are not doing anything, normally the sensor will be sleeping. You're not connected to the one. Only when you set the intervals at 10 minutes or 1 hour, then it will wake up and send you the data, the location of those of the things, whatever that is taking. Okay. Okay. Then let's say you started to move, you start your engine and try to move from the current position. Then quickly you will wake up and send the data. It gives you information that now you are moving. Now you started to move. And while you are moving, it gives you more data. Say, for example, in intervals time, to give you the speed. Say, for example, acceleration or whatever that you set it to give you. So these are the dynamic changes. Okay, the state of the device must change dynamically. So kalau you letak satu sensor and then that sensor does not really change anything, that means it doesn't really give you information apart from the one state that it has been doing all the time. Okay, so it's no point putting a sensor for things that it does not give you any dynamic kind of information. So all you see in the graph, say for example, is just a flat graph, you know. So there's no information, basically as good as no information. Okay. And the last characteristic, it has to be in enormous scale. So this device that need to be managed and communicate with other device, okay, need to be at least an order of magnitude larger than the device connected to the current network. Okay. So the scalability ataupun okay, let's say for example today you put 5 sensors, you need to be able to add more sensors because physical states, things that you want to strike, things that you want to sense, always increasing. So you will find cases where you need more things to sense, for example, and it needs to be able to scale up. So these are one of the characteristics of IoT. All right. Okay, so now we will go into next topic, which is the high-level requirements. Okay, I share with you. This is also something that is produced by E2, International Telecommunication Union. They set these high-level requirements for anyone who wanted to provide IoT solutions. Okay, the first requirement, okay, that you need to do is identification-based connectivity. Okay, the IoT needs to support that the connectivity between things is established based on the thing's identifier, and this includes any heterogeneous identifiers for different things that is processed. Okay, so that means all sensor have unique IDs. So dia tak boleh ada ID yang sama. So otherwise you will not be able to distinguish what is what and where is where. Okay. Second requirement is interoperability. So that means it needs to be ensured that these devices must be able to work with other device in a different manner, in a different connection, for example. Okay. Heterogeneous tadi I dah explain. It's basically a distributed. Basically, is the requirement that make sure you be able to work with the other system, for example. So in IoT, one common language ataupun not language, is actually protocol or something. Is that kalau you talk to IoT punya supplier normally, they will be able to give you some sort of like interface. They call it API, the interface. So where you can pull that data, and it's sort of like a universal language where you pull data from other system with other system. So that is what it means. You need to be able to be operated by other system as well. So otherwise, you will not be able to communicate, and that defeat the purpose of having that connectivity. Okay. The third requirement is autonomic networking. Autonomic networking which includes self-management, self-configuring, self-healing, self-optimizing, or self-protecting techniques or mechanism. And it needs to be supported in networking control function of the IoT. And this is important because in order for IoT or application to communicate with different environment, for example, especially when it has very large numbers or large type of device, you need to be able to switch different type of communication. I give you one example. One of our tracker, dipanggil GPS tracker, but it is also a Wi-Fi sniffer, Wi-Fi tracker. So you can do both indoor and outdoor, kind of like tracking where you are. Okay. When, let's say, there is Wi-Fi nearby, or you are indoor, inside a building or inside a room, your location is determined by the Wi-Fi. Okay. Where you are, okay, relatively they calculate what is the exact location of you. Okay. The moment you go outside, you lose that Wi-Fi connectivity. Quickly, the sensor switch the method to GPS, and it send the data to the cloud or to the server through other means, through say mobile connection. Okay, so now you use Wi-Fi. The other one, after that you use GPS or 3G or 4G or whatever type of network. Okay, so that is what is called by autonomic networking. The other requirement is autonomic service provisioning. Okay. So service provisioning means that the service needs to be able to be provided by capturing, communicating and processing automatically the data based on the rules set by the operator or customized by the subscriber. Okay, I take that example, the same example as tracker just now, the position tracker. So the service that the tracker gives is exact location or real-time location of the object or item that you tag. It can be people, it can be assets. That is the service, and that information is automatically given to you in real-time access. At the same time, you can also view, say for example, how much of a machine, for example, and what time it starts, what time it stops, for example, and all that is automatic. So you don't need people at the back, you know, to look at, okay, at this time it started, and this time it goes down, it shut down, and then you calculate, okay, how many percent of this daily, you know, every day that the machine is running. It has to be automatic. So that is what it means by autonomic service provisioning. Okay. The other requirement is location-based capabilities. Okay, location-based capabilities is something that need to be supported in the IT. Because why? You know, any communication or services will depend on the location of the information of the things or the user. Okay, it needed to sense and track location information automatically. So this is what it means by location-based communication or location-based capability. Like macam tracker tadi lah. Okay, you need to know where it is in the physical world. Okay, in order for you to to be able to know the exact information that you're looking for. Okay, and it can be or may be constrained by some law and regulations, and also some security requirement. Okay, so location-based communication this is basically one of the requirement. So for each and every sensor, for example, you need to have sort of like where it's located. If it's mobile, exactly. Some of the some of the hello. Can I confirm everyone can hear me? I lost the connection just now.
Yes, I can hear loud and clear.
Okay, thank you. Sorry, my Wi-Fi here. I don't know, is it whether my computer or yeah. So I think it's already 10:40. So I've really lost my momentum just now. So maybe we take a 10 minutes break, and then we'll come back at about 10:55. Is that all right?
Yeah, I think we should take a break. It's currently 10:40, so it should be 15 minutes, but I think it's okay to start at 11. So
Okay.
we will keep this link live, so everyone doesn't need to actually left the link. So we will be starting at about 10:55 to 11. Right, so have a good break. Thank you. Okay, hi everyone. So we'll be starting very soon. In case that you have left the link, you may rejoin the link by using the same link. And for your information, we will be having a quiz session after each session. And so you can also refer to the lecture notes or whatever that we have given to you. So if everything is ready, Ama, we can just start now.
Okay, welcome back, everyone. I hope you have a good rest. At least I have. Okay, we can continue where we stopped just now. Okay, I think we stopped at the security. So maybe I just recap a bit lah. So we have covered the high-level requirement. We have covered the identification-based connectivity, interoperability, automatic networking, automatic services, provisioning, location-based capabilities. We have already covered that. So for security, for example, this is also one of the most important high-level requirement that you need to take care of when you implement or design an IoT solution. So because the data that you producing, for example, is susceptible to cyber threat. And some of the information that you are gathering from, say, your drones, especially when you take videos or pictures, those are confidential sometimes, and it is important that security of your network, security of your device, all elements of architecture of IoT need to be secured. So later, maybe tomorrow, we will discuss about the different layer of architecture IoT, where security actually encompasses all the layers. So we need to make sure that in every single step or layer where the data is traveling, from whether it's device or whether it's in network or whether it's in the application itself, it has to be basically secure. Okay. And the next requirement is the privacy protection. I'm pretty sure everyone aware that when we are in a more connected world, even in social media, we are sharing a lot of our privacy. So this is a very sensitive or difficult thing to protect, because there's no black and white. There's always a gray area that you probably have to find. And let's say you want to protect privacy, because some of your client, for example, does not want any some of the data, his data, to be exposed to other people. But at the same time, your system need to transfer those data, kan? You need to transmit, aggregate, and store those data for mining and processing later. So what can you store? What can you not store? So it's gray, So it's best that this kind of protection, the kind of data you are going to take, or you are going to you discuss it properly with your client or your customer, so that they know exactly all those data does not infringe on some of the privacy ataupun whatever sensitive information that they don't want people to know. Okay, and you will find this, I'm pretty sure if you are doing drones, for example, especially drones, a lot of people having difficulty in terms of putting the boundary of what you can share, what you cannot share. Okay. And Google, for example, if you remember, and there's a lot of hype in the internet. When Google go around streets to take pictures of 350, and then you find that people in awkward positioning lah and all that. Okay, so in Malaysia, the privacy protection, we have a law, but for example, in Europe, it is more important. Okay, next level, high level requirement is high quality and highly secure human body. So what is this human body services? Human body related services refer to service provided by capturing, communicating, and processing data related to human static features or dynamic behavior. Okay, especially in, like, for example, online marketing, you are tracking how people buy stuff. You are tracking how people, interact with other people through social media. How people are looking at giving comments on some posting in social media or some videos uploaded on the YouTube. So this human behavior or human intervention, kita capture normally by robots lah kan, because I mean that's the whole point of IoT. Robots capture those data and translate that into something that is manageable for us. So we need to ensure that it is secured in high quality and highly secure related services. Okay, the next requirement is the plug and play. So plug and play ni very simple. I can say that most of our device sensors money is just place and track. I mean, for example, you don't really need to install, do some wiring lah, do some configuration. No. So IoT, it needs to be plug and play most of the time. Okay, so if you buy IoT ready or sensor or IoT ready devices or actuators, normally it's already enclosed, so you don't have too much of installation steps that you need to go to. Okay, so you can deploy these things very quickly, and you can start getting the data also very quickly, and you will be responsive to whatever input you give in terms of the output that the device have to give it to you. Okay. The last requirement is manageability. IoT applications usually work automatically and without participation of people, but we need to ensure that the entire process we can manage. Okay, so it cannot be fully autonomous juga. So all the data, if is rubbish in, rubbish out, so we need to be able to at least manage, filter some data, make sure that this whatever information that we got from whatever sources is within something that we can manage. So those are the high-level requirement. So if you are implementing IoT solution, you are thinking of implementing IoT solution, whether from the drone services, for example, which I think most of you are going to look at. So make sure you build in all these requirements so that at least you have a step, or you have a what you call that, guide. What are the things that you need to be designing it for? Okay. Now let's talk about, okay, you have the requirement, you know what is the characteristic, so where can you apply? So I'll give you some like settings, some sort of like indication of place or space where you can apply, or where people are already applying IoT applications. Okay, so on the right side, on the left side of my screen is a setting and some of the examples of the application. The first setting is human, you yourself. So it means that you are attaching device whether you attach like your phone, your watch, for example, or inside your human body lah. And some example is wearables, ingestibles to monitor or maintain human health and wellness. I'm pretty sure everyone have, you know, smartwatch that can, you know, count your steps every day. So we have a recommended step that you need to be at least 10,000 steps a day in order for you to be active or considered active, or super active, 12,000 steps a day, for example. So that is already an application of IoT. Okay, a much higher higher level of application will be at the hospital, for example, for disease management, increased fitness, high productivity. So COVID-19, for example, you have My Sejahtera app. So that is another form of IoT, right? So we tag, we basically record every single location we visited. Let's say you go onto a train, you tag, so people can see where you are, where you have been in the last 14 days. So those are examples of IoT settings on human. Next setting will be your home. Okay, the building where people live. Okay, I'm pretty sure some of you have heard about smart homes systems. Okay, at your house, for example, you have air conditioning, you have lightings, you have kitchen, you have fans, and smart home means that you can control, or the house can switch on and off by itself. You know, let's say for example 10 minutes before you and start to, you know, maybe switch on the aircon, you know, and maybe you know, whatever you said lah. If you like to make coffee, then maybe it you know, start the machine right away. So that is a home controller or security system in house. So very simple example, like my house, I put some CCTV. Yeah. So every time there is some movement, if I'm not out, so and I can actually view what is happening. Okay. Next setting, I would say that is promising also is the retail environment. So retail environment refers to the spaces where consumer engage in commerce. But it can also means that it can also, you know, anything that you make your transaction every day, stores, bank, restaurants, arena. Okay, anywhere a consumer consider to buy. So right now, if you go to supermarket, you already have machines that you can actually buy, pay using credit cards. You know, your self checkouts in stores. And if you go to like houseware kind of store, you can just pick from the system, and then there will be a pick and place system where it will go and find the specific product that you want, and then you just go to the pickup area where you picked up the items that you wanted. So those are the retail environment. And it goes beyond that. Actually, implementing retail is one of the largest usage of IT application actually, and it relates to how people come into store. For example, I've seen some use cases where, you know, they use this data that they gathered. You know, when people comes in, say through door A, door B, or door C, it goes through the shelves, and normally, and then they study the pattern. So when the pattern, let's say, shows that most people will go to shelves that they're most interested in, they don't actually go to browse all other stuff that they don't need, right? for example. Highly likely that people will just go for the store for things that they need and buy and then go off. So when you wanted to place some sort of like panggil apa, product placement kan, you nak susun which shelf, which product you want to show first, for example. So you study those pattern and those are the in order for you to increase some of the product that you want to sell. So IoT application in retail is massive in the sense that there's a lot of creative stuff you can do, and this is actually exciting for IoT. So the next setting will be your office. It's simple thing as energy conservation. Contoh, we have in office, let's say if a big office, you pay air conditioning or electricity, you pay for lightings, and most of the time, sometimes in a meeting room, for example, people left the lights open, the aircon open. So smart offices or smart buildings will basically do some sort of like automated energy management, okay, and also security. I have some case study, or not really case study, more survey results, and how people actually applies on the offices. And later in the next session, I will share that. The next setting will be factories. So factories, as you all know, is a standard production environment. We produce products, whether it's finished product or semi-finished product. Okay, and one thing about manufacturing is always repetitive work. If you're doing the same thing every day, and it's not only limited to production. It's also limited to like maintenance, for example. And what we are most concerned about when we are talking about factories is mostly operating efficiencies, optimizing equipment usage, and also inventory. So these are the examples, some examples that IoT help in terms of getting value for the factory settings. Okay. Next setting is the work sites. The definition of it is the custom production environments. So it does not necessarily be in one site, but it could be in multiple sites, or that site could be moving. For example, in mining, in oil and gas, in construction, from one to the other side. You move from one side, after it's finished, you move from the other side. Okay. And the things that you look for, the values that you wanted to get out of the IoT application is the same as factories. For example, operating efficiencies. For the machines that you have, you want to avoid unplanned downtime, so you need to do some sort of like a predictive maintenance. So those are one of the most famous application of IoT. And for the workers, where the type of work is 3D, dirty, dangerous, and what is it?
Dangerous and demeaning.
Demeaning, for example. One of the important parameter or important things to look for is the health and safety of the workers. Okay. Next settings is a vehicle, especially logistic, your own vehicle or your company's vehicle, and supply chain and management, supply chain logistic, for example, they have one company probably have a fleet of trucks, a fleet of machines, vehicles, and what they're most interested in is real-time, say for example, real-time location of the vehicles, conditioning based condition the vehicles, usage based, how much is the utilization rate, for example. Okay, so those are the application with regard to vehicle setting. Next setting is the cities, the urban environment. So especially important for local authority, you know, like city council, even the state government, or even the federal government. Yeah? Because why they own these public spaces, where people comes, and when people comes, there are always problems associated to that, whether it's environmental problem or traffic problem, okay, or energy usage kind of problem, okay, because you are managing all that in the city, so that is within your as a city council or as a government. It's your responsibility to make sure that some of those services like public safety, public lightings, whatever, is being taken care of. Okay. And last but not least is the outside, setting or outside, between urban and other setting. And that includes some transportation systems, say for example, railway tracks, autonomous vehicle, flight navigation. So it's not really urban, so in between urbans, in between cities, for example. So we're talking about mobility of people, mobility of goods. So these are the settings that you can apply, or people already apply IoT applications. Okay, so that is basically end of this segment. Next, we will be talking about factors, enabling factors for IoT, as well as the enabling technologies. So in order to understand the phenomena behind what is the pushing factor, what makes people move towards, implementing IoT, and what makes it, what are the enablers? Enablers means what you call that, before this you cannot do it because of certain limitation, but now you have that solution to overcome that limitation. Okay, so let's talk about that in the next half an hour, maybe half an hour to 40 minutes. Okay, there are 6 factors, whether it's technology or market trends, that have been key in enabling IoT. Number 1 is ubiquitous connectivity. So ubiquitous means what? Anytime, any place, anywhere. Kan? That was ubiquitous. Dulu, a few years back, without a mobile phone or smartphone, we use the connectivity is limited to, okay, when you have internet, everywhere we have direct connection to internet. So when you have that trend, or you have that connectivity, that makes it that enables IoT. Okay. You just extend the ubiquitous connectivity to things. The second one is widespread adoption of IP-based networking. So I will also explain internet protocol networks. We used to have IPv4. We use now with IPv6, and I'll detail a little bit, a few more minutes to basically talk about that. And that actually relates to one of the requirements, which is heterogeneous or identity-based connection. Okay. The third factor is advances. So with big data, aggregate data that is unstructured, And there are underlying technologies that actually enables this data analytics. So we will discuss that in much further the next section or tomorrow when we talk about the architecture. And then number 4 is the computing economics. What it means is that the prices of the cost of doing analysis, storing data is getting lower and lower and lower by the day. So the barrier last time was that to have that kind of analytics is very expensive. But now the cost has gone down. So computing economics has gone down. So it enables now the market trends, enables the implementation of IoT. The last, not the last, the second last is the rise in cloud computing. We used to do analysis of computational activities within our own PC or a desktop that we have in office. And we pull the data from the server last time. They pull data from the cloud. But more and more, I think in the last 4 or 5 years, people are talking about cloud computing, and we make the analysis or we make those calculations not in our PC, but itself. So those is because the amount of data you need to store. Kalau you nak download all those data yang petabytes, it's too big, for you to store in your local desktop. So you cannot do big analytics there. So cloud computing enables that. Because when you want to do identification, you need to overlay a lot of those data. One of data, for example, video is a huge data. And so before cloud computing exists, it's almost impossible because you cannot store. You probably store data. You have to basically trim it first. There's a lot of process involved. But now with cloud computing, you remove some of those barriers and makes IoT more implementable. Okay, last but not least is the miniaturization and declining price. Yes, one of the most important thing is the sensing of data, the gathering of data or creating the data. Sensors, one of the most important elements of IoT, used to be very, very expensive, and they are quite big in terms of size. Now the trend is you can see that all the sensors now becoming smaller and smaller and becoming cheaper and cheaper. So all these market trends, okay, I will actually explain this in a bit more detail, but I think I already talked about it a bit more. So tak apalah, we go through this quickly. Ubiquitous connectivity, provide connectivity to everyone and everything, everywhere and every time. So low cost, high speed. So what it means is the pervasive network connectivity, especially through licensed and unlicensed wireless services and technology, and makes almost everything connectable. Widespread adoption of IP-based networking. So IP now has become a dominant global standard for networking. It provides well-defined and widely implemented platform in software and tools. And what it can also use in a very broad range of devices. Advanced analytics, okay. People are coming up with new algorithms, rapid increase in computing power, and data storage and cloud service. This is also one of the elements that makes advances in data analytics. When I say advanced, it means that you will be able to aggregate, correlate, and do the analysis of vast quantity of data in much faster time. So used to take 2 weeks, 3 weeks for you to just aggregate data, just to make sense of data, just to convert from, say, for example, pictures or types in different language Now, with some of the technology, macam contoh text to speech, technology, speech to speech recognition, technology, you can have computer does that. You don't have to do it yourself. So, in a computer does it much faster. So these are what it means by advances in data analytics. Computing economics, industry research, investment in research and development of manufacturing has led to greater computing power at lower price point, and power consumption also very low. Cloud computing, cloud refers to remote networked computing resources to first process, then manage and store the data. And it allows small and distributed devices to interact with powerful back-end analytics and control capabilities. Miniaturization and declining price. Manufacturing advances allows cutting-edge computing and communication technology to be incorporated into a very small device. And you have a very small sensor, very small drones, and this basically comes with the cost, the declining cost. Let's look at evolution of computers from 1960s to 2020. So 1960s, big mainframe there. So computers used to be very huge. 1970s, they started to have mini computers. It's called mini at the time, but it's not really mini. Okay, and then 1980s, people start inventing workstations, or people in the workplace started to use computers. And before this, it used to be exclusively for big research company lah, big say for example utilities or energy companies. In 1990s, the personal computer comes to our lives, and people are starting to buy computers for themselves. So this is where Windows, started to have taking traction in the market and now dominate everything. All right, and 2000, where the laptop first come into the picture, so it becomes smaller and smaller. Now it's become mobile. Okay, 2010, where smartphone started to smart in the future. So between 2000 and 2010, people used to bring a big laptop to the work, and now they don't really need to. Everything is in the smartphone. And 2020, we have this something called millimeter scale sensor, and this sensor works as basically as a computer, a small mini computer. Okay. So, tadi we talk about factors, we talk about market trends, we talk about what is happening in the market that enables the IoT implementation. And let's talk about technologies lah. Okay, I take this example. There are 5 key technology that makes up IoT architecture. First is a sensor, followed by the network, and then standards, augmented intelligence, and augmented behavior. So sensors, by definition, is a device that generates electric signal from any physical state or condition or an event. Okay, I give you an example. An accelerometer costs fallen to about 40 cents from 40 cents from $2 in 2006. Now every phone have accelerometers already. So that's why you can actually say use your phone to track how many steps you are taking every day. Yeah, because inside your phone you have small accelerometer. So the cost has been very low or declining over the years. And this similar trend have made other types of sensors small, inexpensive, and robust enough to create information from everything, from fatal heartbeats to conductive fabric, okay, to jet engines even. Okay, so next technology that we'll be talking about is the network. Okay, when we wanted to communicate with other person or other machine to machine to machine, it has to go through some sort of communicating mechanism. Okay, and most of the time it's based on electronic signals. So wireless technology, for example, networking technologies, have gone tremendous to a tremendous advance. It now can deliver bandwidths of big data, 30 megabytes to 1 gigabytes per second, and you can have that connection almost everywhere with 4G, and now we are looking at 5G, okay, which is 10 times more powerful than 4Gs. The next technology is the standards. Okay? What is the standards actually? By definition, standard is commonly accepted prohibitions or prescription for action. So certain things is like guidelines, not really guidelines, but close to that. So how do you, the way you communicate, it has to follow certain standards. The way you pick your sensor have to follow some standards. And other requirement, higher level requirements. So those are standards. So if everyone follows the same standards, so what we can say is that it can improve your interoperability. So if, say, I'm using radio frequency, and other person is also using radio frequency, so highly likely is that my system and his system can be integrated. Okay. So this is what it means. Technical standards enable processing of data and allows for interoperability of aggregated data sets. And we should see in the future from the industry consortium or even standard bodies, we started to follow certain, produce certain standard that everyone will follow. At the moment, IoT is a very big thing, and its application is very, very broad. So we don't actually really have certain standards. What we have is as best as a recommendation from E2, International Telecommunication Unit. It's a body under UN actually. But we have seen some industry people making up some consortium, and start to write up the kind of standards that they wanted everybody to follow. Okay, and where this goes, we have to see. Okay, at the end, who will be the most popular standards or whatever. Okay, in engineering, I have to say that the standards is pretty advanced already. So let's say you want to make a house, you have a standard to follow already. You don't follow the standard, you cannot be certified. So you want to manufacture cars or vehicles, you have to follow certain standard already. Okay, that's how important the technology or the standards is. Same with IoT, but right now IoT is still sort of like vague because it's new. So the standard has not been set as clear as other industries. Okay, next technology we're talking about augmented intelligence. By definition, it is an analytical tools that improve the ability to describe, predict, and exploit the relationship between the phenomena. Okay. Now we are dealing with really, really big data, petabyte size data, and we need to be able to sift through those data and analyze, even populate it with unstructured data sets. Okay. So software that learns might be substitute for human analysis and judgment in a few situations. We already seeing this. Say, for example, when I was aerospace engineer, we used to collect data that we get from tests. We got from material testing, we got from system testing. We correlate the data. But before because the data is so big. Let's say, for example, when I design an aircraft, I have to imagine that the aircraft will be exposed to thousands and thousands of cases. Okay. So it's impossible for you to actually calculate those data 1,000 times. Okay. So what we do is we program the calculation or the analysis using some programmable tool. So what the tool does is you take the input, put into the equation, and get an output. And it does that many times much faster than human brain or much faster than my fingers, right? So this software, that is still a programmable. I can say I press one button and I got the results within 10 minutes, 15 minutes. But next forward is that I may not even need to press that button. Okay, I just need to feed the information, upload it, boom, then it comes up with results already. Okay. And the results that it creates happen going through a process of learning. Okay, some data is not truthful, cannot be trusted. So there must be some sort of like logics that the computer learns. Maybe you exclude the data or you do some adjustment to those data. Okay, so that is what is the technology within this framework, which is called augmented intelligence. It's a big word. It's not really a common word. So when I say augmented intelligence, it's not really intelligence artificial. So it's like I have machines that helping me. It's more like human and machines working together. So that's why it's augmented. It's not artificial, as what it means. And then you have a technology augmented behavior. Now you know what to do already from the analysis. You know what will happen. You know how does the processes can be improved. Now I can take the action as a human to make changes to my to the current operation, for example. Okay, manually I can do that because based on the analysis result, I can basically the intelligence software or whatever can tell me what is the next course of action, but it cannot do that for you. With behavior, augmented behavior technology, you can actually do that for you, right? So going back to Kevin Ashton definition, what he says is that it's not interesting if the IoT informs you only. It must be able to do it for you, do the corrective action for you. So the behavior, augmented behavior, is the underlying technologies that improve the technique to comply to the prescribed action that you initially have in the augmented intelligence punya layer. All right, so that's basically all about what you call that factors and also technologies that implement IoT. So I have created one slides or one section basically talks about IoT and drone technology. So because let's put some of this training in context. Okay. I understand that the training is for drone, and most of the people that join this training initially is in this line of knowledge. So, like I said this morning, the current drone you have, the drone itself, to be honest, is a form of IoT lah. Why? You have a drone and you control that using your phone, kan? And that's two device communicating, right? It goes through some sort of like communication network, their own network, but it may not be connected to the internet. So the only way, the only data that you can view is through your phone. So it's limited to that. So how do you then make it an IoT? Simple lah, just connect it to the internet. Okay. So IoT or drones, UAV, you can, some people in the industry term this as emerging form of new IoT device. So where it's located is still at the device or sensors kind of layer. But it's more mobile in the sense that it can fly in the sky with full network connectivity capabilities. Okay. And now with the emerging technologies like 5G and 4G networks, these have driven the drone technology to be equipped with more sensors, more cameras, or more what you call that, functions, okay, in delivering Internet of Things, IoT services. Okay. So imagine the amount of sensors, sensing capabilities that you can attach to a drone, almost limitless. So it all depends on what kind of problem you want to solve. So I will take examples and use cases from our past work with Aeronerve in the plantation, in the farming settings. But before that, let's just see how drones use cases are changing. And today, everyone can own a drone. You can buy the drones, whether commercially available. They are commercially available in any IT stores, for example. But industry proponents have looked at the massive growth in IoT and IIoT, and we are seeing that more drones are now performing more important tasks. Okay, the use case is a lot. I don't intend to discuss that in detail because really what you can do with drones when you connect to internet is massive. Okay, but what we discuss is what we have done. So I think it's better to do that. And Aeronerve is here also. So I don't know if you have anything to add on to the discussion. Please do. Maybe share some of your part of the work with us later. So today I'll just give you a sniff through of what have been done in terms of IoT and drone, and how the two systems, or let's say you have a landed sensor and the flying sensor, which is the drone, how they match together within ecosystem to deliver one solution. Okay. So traditional farming practices basically rely on mostly intuition and experience. So when we talk to farmers, normally whatever they do, in terms of the tasks that they do every day, the process that they do going through every day is based on experience that their predecessor or they themselves have gone through. But precision agriculture relies more on data and analytics. So traditional farming now, moving towards precision agriculture. And smart drone enables a lot of application in precision farming techniques by the farmers. Okay. And together with another kind of technology, which is the wireless sensor network, you can actually now apply automation in agriculture. Previously, our automation automation we normally associated with manufacturing, but now with the combination of these two technology, it is possible now to automate some of the maybe highly heavy duty kind of tasks, more to robots and tractors and all that. Okay, precision agriculture use specific sensors and software to ensure that the crop receive exactly what they need to optimize productivity and sustainability. When we talk to, say, for example, we talk to lembaga Nenas, Bau Pembangunan Lembaga Perindustrian Nenas Malaysia, LPNM. So farmers come to them, let's say for example, to learn how to tanam nanas or produce nanas, for example, a pineapple. So they will go through a certain sort of like classroom. And in the classroom, they will teach you everything about the plant, everything about the process. And they start from like clearing the land, and then start making some batas, something like that. And then from there, you put fertilizer, you put everything is scheduled, kind of. So everything is scheduled, meaning this time, this date, you do this, you do that, and semua ikut SOP. And then you apply that to every single acres that you have. So standard. So when we ask what are the basis of this SOP, or standard operating procedure, is that it comes from the feedback from the farmer. The farmer say we do this, we do that. Some of those data yearly they give you like set of questions, and they ask the farmers to basically fill that form. And obviously, when we ask the farmers, I only basically what they feel is the same as they feel last year, for example. So the truthfulness of the data is not there. So the SOP is not really dynamic in the sense that it improves based on actual data. That's why precision agriculture, okay, one of the main benefit of it is you can evolve your SOP, and what it leads to is basically something we call site-specific crop management. Because before this, you just use SOP, so you apply everything the same for every single plot. But if you do a bit of measurement, you can see that some plots needs more, some plot needs less. So you can actually use the data that you gather and only apply treatment according to what the plot needs, for example. So you, in a way, apply your SOP differently for different plots. Okay. Right. So drones, IoT drones. This is the term that people are coining in the internet. If you go search what is IoT drones, IoT drones is simply drones that is connected to the cloud, so you can actually access whatever the clone is doing. So, Nizar, you are free to jump in and explain a little bit on this drone application if you want. Is it not there? It's okay lah. Okay. So typical architecture of agricultural IoT application is that you have sensors on the ground, which is something called wireless sensor node. Okay, it's actually a network of sensors. So the other day when we were visiting the Jalan Kebun, okay, I think one of the questions that was asked is how do you correlate the accuracy, of each data from the sensor. Okay, this is one of the method. Okay, something called wireless sensor node, meaning all these sensors are connected to each other. Okay, so data that you get from different sensors on the ground, you use it to correlate, and if there is any pattern that goes outside of the norm, you could basically flag that as, focus area. It's not just about whether something's really happening on the ground. It's also so manually what we do is, okay, standard SOP, when we first do our POC, for example, POC is a proof of concept kind of like projects. So we will take data, we put several nodes, several sensors, and then we take readings, and we tend to mix the kind of sensors we have, whether it's from different manufacturer or different, because we wanted to test whether or not the result is the same. Okay? So when we have something like anomaly, something that we don't really expect to happen, so the value goes up or down drastically, or not within the what you call that, range that we expected. The first thing, we will go on the ground. We will test first whether it's a sensor problem or whether it's actual thing. So we have probably portable devices, something like that. So when you do that, then you will be able to know whether or not the soil is actually having the change of condition as per the sensor is saying. Okay, and then we record that data. Yeah, we record that data. You know that if this is the case, this is the trend, and this is the pattern, means that it most probably is a sensor problem. So when you create that network of sensors, okay, you apply a predictive model kind of algorithm that can tell whether or not this is problems that comes from the sensor or that comes from the soil itself. Okay, yeah. So that is one of the method that you use to basically. Okay.
So, okay, we got one question. How do you decide where to put the node sensors and the distance apart from each nodes? By Anwar and Ashraf.
Answer it?
Yeah, can. So, hi guys, Farhan here. So, based on our pilot project and a recommendation from the manufacturers, what we've done previously is 1 acre per sensor, as prescribed by our manufacturers. So that is what we have done. That is the decision. So one sensor for 1 acre. This is specifically true for soil monitoring sensor. With regards to systems like water quality or anything else not soil related, we will normally put at the source of the water, but that is different. But this one is specifically for soil. And then there's another one. During the visit, we were told only 1 soil sensor was used per acre. It had insufficient to measure variation in soil properties. Thank you, Lee Boontek. It depends really, because soil by right is homogeneous, meaning that the properties of 1 soil per acre is the same. So that is the assumption based on our deployment. We are working with agronomists as well as the manufacturers, and that is the result that we got. Because it looks highly insufficient, but really how you take the reading as compared to the typical way of taking the reading is almost similar. Because why? From the agronom, like I explained on the farm last time, Agronomics also will take the sensors. Will take the samples in the same way that we took. They will take representative representative readings and not the absolute or actual, not the absolute reading. And the reference representative reading for them is enough to actually decide what kind of fertilizer, what kind of budget that we need to do, that we need to prescribe for the actual land.
Okay.
Yeah.
So let me add on what Farhan had said. Okay, so the keywords here is sufficient or not 1 acre per sensor, kan? Okay, it all depends on the type of soil. Okay, first thing first, we do soil survey. What kind of soil, what type of soil in a plot, say for example, in a plot, one plot of 1 acre, say for example, if you have 2 different soil types, can, then you need 2 sensors. So it depends on what are the soil punya condition or punya categorization, for example. And the way we sample is the same as how you do it manually. Okay, the location. Okay, I mean, you pun tak ambil every say 1 meter ke apa kan? No, you don't do that. Okay, you take samples from maybe 1 acre. You take 10 samples, kan? You spread it out, and then you bring to the lab, and this is how you do it. Okay. Of course, when you first started, first thing first, you check the homogeneity of the land, the soil. And you put your sensors, you get the reading, and if the reading is good enough, and you can establish, okay, 1 meter, 1 acre per sensor, that's enough to represent the readings. Okay. And if you have a level of trust, say you don't trust, for example, it's commonly true. And instead of doing the information, you add another layer of SOP. Okay, if you don't trust it, okay, when you have enough data, big data, then you probably will trust the system better. So that is the reason why we need to see patterns, we need to see analyses, okay? And that is the reason why. So let's say, for example, if you don't trust 1 meter per acre, 1 sensor per acre, you can put 5 sensors per acre, no problem, right? Get the data for 6 months, for example. Look at variation of those data, whether or not it's representative or not. Then next rotation, you can change. Can when you have your want to buy so many nodes, the soil sensor, you have to do that lah. Otherwise, you have to do so many and banyak sangat. So the cost will be prohibitive for you to actually implement it. Okay, so it's very important for us when we started this project it takes. And the most people who has actually done this is testing times, right? Because it's their product, right? So of course we follow them as well. So they say the maximum is one acre. So maximum we can do 1 acre. So we limit ourselves to 1 acre, something like that. Okay. Of course, if you go to a different manufacturer, they will advise different way, maybe 10 meters, I don't know. Okay, so it depends. So I hope that answered the question. Okay. All right, so that is the sensor. So I'm talking about sensor network, how the sensor connected to each other. they can check each other when you're reading. Then they can see patterns that which are not right or not wrong. They can actually do some adjustment to it if it's intelligent enough in the future. So I'm not saying that it can do that now, but we have to go through to that phase in order for us to be confident about it. Okay, and on top of that, then we have this vegetative drones that. So you have another set of data. One is the pH, soil pH. Okay, IoT drones, dia boleh take pictures. And what you can do with that pictures? You can first recounting. Okay, if you have 1 acre, then you can count lah. Kalau you have 100 acre, 200 acre, susah kan nak count even the plant one, you don't know. Kan? Some plant mati. Okay, so the number of healthy plants how much you can produce in the next harvest, for example. So you need that information. So I've seen some tree planting, tree counting is something that is very basic for IoT application. You know, I mean you can do it within using a commercial drone pun boleh, no problem. The other application that you can do, so this is an example of tree counting lah. I think some of the participants also showed me last time. Was it me? I can't remember. That they have already do this, you know. So you can pinpoint how much you can pinpoint the location of each tree or plant and do the counting. This is one of the example of tree counting. Next is the health monitoring. So this is using infrared. Infrared. What you can do is you can estimate what is the location of the healthy health status of the plant. So if it's different color, so it's probably not healthy or maybe dead. So you're basing on the color coding lah. So that's one of the application of plant health monitoring. Other application is digital surface modeling. So basically, it's looking at the elevation. So you know which region have higher elevation and which elevation, which region have lower elevation. So in the event of heavy rain, you know where the water will flow and where is the location where you need to apply a bit more care in terms of the flooding mitigation. So because the number one enemy is water, so it's yes. So pineapple is something that you don't really need to water, but if you have too much water, it means you flooded for more than 7 hours, the plant will die. Okay, on top of that, so we gather data from the soil monitoring, soil condition, pH, NPK, nitrogen, potassium, and phosphate. And then we can also check the water moisture or the soil moisture, soil temperature, and then ambient temperature, ambient humidity, and also rain gauge. So data you get from say plant monitoring, you overlay with pH, then you overlay with NPK, and then you know location that have a problematic area. Let's say, for example, the color kuning, the color is yellow, for example. The nutrient content of the soil is good or not. So you can actually specifically manage that plot, okay, by having those two data overlay together. All right. So that's at the end of module 1. We have about 20 minutes before we take off for lunch. So I would, we have a questionnaire, some sort of like a mini quiz lah. So I think in the chat section, did you post in the chat? You post in the chat?
No, yeah. I think we answered the questions first.
Oh, you got questions. Okay.
Yeah. So we got some questions here. The first one is, can soil moisture be measured using drone to monitor infrared signal too? I think this one Nizal can take the question. Nizal?
Sure. So actually, we haven't done it yet, but logically, I think it is almost, or it is possible to identify is there any variance of moisture by looking at what are the reflection index of the soil surface. But yeah, if you just rely on looking on what happening on the soil surface, I think it's not complete perspective on the soil condition, because soil is not just what it is on the surface, but it is also affected by what it is within the soil itself. So I think maybe there are differences, but is there the question is there any reliable difference to actually implement drone to monitor the soil moisture? That's my my opinion on that matters. And another question by Fakrul, based on your experience using image captured, is it possible to determine? I think the same, almost the same opinion as asked by Mr. Lee. Again, yeah, of course, the function of drone is actually to get all the data, which can be only seen using aerial machines. I mean, in this case is drone lah, but we cannot. I mean, to actually truthfully to check is there the difference in the soil quality. I think it's better to use ground sensor to measure the soil quality. Whether if yes can, then we have to talk about how practical is it to put into business. So that is one of the things. Like for vegetables plantation, we can actually identify which vegetables is actually healthy or not healthy by using multispectral imaging. But again, when you put into business practical, then it is not worth it for farmers to actually subscribe for drone plant health monitoring, because for one ikat of sayur you can actually only get, I mean, maybe less than 50 cents. Then you have to pay thousands for multispectral imaging. So I think in one aspect, does drone can detect the differences? I think drone can detect using multiple kind of sensor. But in terms of business practicality, I think that is one of the challenge lah. So I hope that answers question by Mr. Lee and also Fakrul.
All right. Thank you for sharing, Mr. Nizal. We have another question. Can soil moisture be, how do you set baseline for the current site before implementing sensors? Mr. Eric, can you clarify what do you mean by baseline? Baseline of what? The soil condition? Mr. Eric?
Soil condition.
I'm not sure. It's okay.
Okay.
So,
how do you set baseline?
soalannya
Okay. So basically, in any experiment, you need to have like a starting point or datum point, I have to say. In our case, when we implemented the POC at the the pineapple plantation. The agronomists already set that baseline lah. So they have data that they have gathered over the years that they actually shared with us, and these are the determined by the statistical method that they, or experimental method that they themselves are doing, right? Okay, when we put our sensors, the first thing we check is whether or not the sensors too making sense compared to the data that he has. So we take measurement at the same time as the data that the agronomists take. Okay, same time you put data, my sensor there, you get the data at that time, or maybe within 1 hour, 2 hours time, while they take the sample and bring it to their lab. So it will take them 2 weeks to come up with the results, and then we compare the result based on that. So that's how we set the baseline.
All right, many more questions, please, before we take a break. More? All right, so if you have any more questions, please let us know. Yeah. Yes.
Right. I have a question. So may I know that how's the current? Yeah, this is new. I have a question. So may I know how's the current the market response, or how popular is this technology in Malaysia, like our application of IoT? Is it widely spread, widely applied, or it's still very new in Malaysia? That's my question.
So just to repeat your question, you want to know whether the adoption of IoT in the market, is it?
Yes, correct.
Yes. Okay. All right, so by experience, this year compared to last year, in terms of the leads that we get, the interest that we get, every week we have new interest. I have to say, after MCO, every week we have new interest. So from my experience, I can tell that there is a lot of movement from the industry people, not just in agriculture, but also in logistics, for example, in manufacturing, for example. They are looking for these kind of solutions because it's broad. You know, the application is everywhere, right? So what the playing ground, the market size is much larger. Okay, I have data from some studies that mean that I will basically go through them in module 2 later. So we will discuss this in a bit more detail with database data. Basically, you can see the graph, and then from there, I think it's better lah. If I just tell you that we are having a lot of interest and all that, maybe it's just work for us, can. But let's look at some of the indication or market study. You look at the CAGR numbers, you know. You look at the Malaysia punya context. I have another section that we only just talk about Malaysia punya market potential. Okay, so yeah,
I have
module 2 we will discuss that in a bit more detail.
I have another question. So regarding the sense, so when you apply sensors to the field, right, is battery life a hindrance, or you guys manage to solve this problem? Like, because a sensor needs battery to power, right? So it's battery life a problem to you? It's
battery life is a problem in general, okay, but in the market there are solutions to that, and we use the solution that actually tackle that problem. So I will discuss about this maybe in the architecture tomorrow in more detail. But what I can say now is that it depends first on your sensors, and your sensors is riding on or using certain type of network. Okay, and your sensors have to be basically smart in the sense that when it needs to send data, or what condition, and if it's not send data, you need to make sure that it's sleeping kan. Okay, so there are various type of network that you can average on. Wi-Fi, for example, is known for very high apa nama high battery usage kan, high power punya consumption. We use LP1, which is low powered wide area network, and it's a proprietary protocols by Sigfox. And our sensors, and this Sigfox punya network is specifically to tackle those low power power problems. Okay, and the batteries that our sensors right now having can last at least 2-3 years minimum. Okay, and how it works is through limiting the type of data, or the number of data that it send over. Okay, they are trade-off lah. Basically, if you want more power or battery lasts longer, the trade-off is how much data can you send over to the. So they are trade-off. So it's limited in terms of number of bytes that you can send over, in terms of the basically the length of the data, but you get longer range and longer power. So tomorrow we discuss about the network and also the sensor in the architecture, then we can see a lot more examples. So when you choose, say for example, you want to choose your problem, your problem want to solve. Say, if battery is a problem, then you have to choose a suitable network for that, suitable sensor for that. If a battery is not a problem, let's say for example in a greenhouse, and the other day we greenhouse, battery is not really a problem. So you have power point there. So you can actually choose network and also sensors that suits the condition. Okay, does that answer the question? For now, you get
yes,
more.
Yes, for now.
Okay.
So basically, if I want it to be like give data in real time, it will consume the battery faster.
Correct.
It will...
So you need to be smarter lah. Smarter in the sense that kalau, let's say for example, I give you example, one very simple example. You wanted to know where your people are located, or usage lah. Basically, you want to know, let's say your asset is moving or not, or doing work or not, kan? So basically, what you want to measure is the usage of your asset. If your asset is not doing anything, you should not. You can set it so that it sleeps. Don't need to send data. The moment you move, the moment you start to do something, then baru dia start the data. And then while you're doing something, you'll start to send data more frequently. Something like that. That is why smart sensors, this is IoT sensors. These elements need to be in the sensor. It's not any sensors you can find. It has to be smart because of these issues that you see. Okay, all right. You want to share the?
Yeah. Right. So guys, we will, like what Mr. Ahmad said, we will have like a mini quiz. I'll just pass you the link now. Later you can do it after lunch, and we will take about 15 to 20 minutes for you to answer the questions. If you're done, let us know. Then we can continue with module 2.
I think Nizal has shared the slides for today's slides. So if you need to refer to the slides to probably answer that question, okay, no problem. Okay, this is basically it's for us also. So we wanted to see how much effectiveness of the training and all that. Actually, this is also first time I'm giving training over visual live. Normally we have a classroom and a bit more activity. Okay, back to Nizam maybe.
Okay, alright, thank you. I think we have come to the lunch time. So we will keep this link off. So when everyone is ready, maybe we can get back to the link at 1:55 p.m. and then we can start at 2 p.m. Right? So
Okay.
hopefully everything is okay, and have a good lunch. Thank you.